Hello, welcome back to 7-2. We are integrating exponential functions in this video. Remember, the derivative of a exponential function e to the x is just e to the x. So when we integrate e to the x, it is e to the x, and that's what's beautiful about base e. We'll talk about kind of the reverse chain rule in this video, and then also to what if our base is not e, what if it's a different number. We'll go over those rules here. All right, so covering the exponential functions, the antiderivatives. Again, the integral of e to the x dx is just e to the x plus c if it's indefinite, right? There's no bounds. Always make sure you add your c, okay? If your power is a function of x, then in order to integrate, you have to have that reverse hook, right? Or the reverse chain rule. So we'll see that, okay? And again, the antiderivative of e to the u is just e to the u. So we'll see that. The first example, number 5, is dealing with this type of function here. If I have the antiderivative of a to the x, right, a base that's not e, then when we integrate, we have to go ahead and divide by the natural log of that base, okay? It's like if I was taking the derivative of this, I would multiply, or sorry, not of that. If I was taking the derivative of a to the x, I would multiply by the natural log of a. So when we do the antiderivative, we have to undo that, right? We divide by the natural log of a, okay? All right, so without further ado, let's go ahead and look at example 5. And we are asked to integrate from 0 to 1/2, 4 to the power of x squared minus 1 x dx. So this is a exponential function, okay? And what we're gonna have to do, note, is that our exponent is a function of x. So what we need to do is I need to take the derivative of this. So the derivative is 2x, okay? So I need a 2x hook, right, to get rid of this. So I have the x, notice I have the x accounted for here, okay, but I need the 2. So what I'm gonna do is I'm gonna go ahead and rewrite this. So from 0 to 1/2, 4 to the power of x squared minus 1, okay, and I'm gonna write x dx, okay? So I need a 2, I have to introduce that, right, to get my hook. So I'm going to introduce 2, and when I introduce it, I have to balance it, okay? And I'm going to actually do this with a different color, okay? So I'm introducing a 2, so I have to balance it with a 1/2, okay? So I'm going to go ahead, and now when we integrate, right, this hook, it goes away, okay? So I have 1/2, okay, times, now I'm going to integrate 4 x squared minus 1. So the integral, right, of an exponential function is the same thing, okay? But now since my base is not e, I have to divide by the natural log of that base. So divide by the natural log of 4, okay? And my bounds are from 0 to 1/2. So now I have to evaluate, okay? So this is equal to 1/2 times, I'm going to plug in 1/2, so this becomes 4. 1/2 squared is 1/4. 1/4 take away 1 is -3/4. Natural log of 4 minus 4 to the power of 0 squared. 0 take away 1 is 4 to the -1st, divided by natural log of 4. And there's your answer, okay? You don't have to simplify. That's it. All right, there's the first example. The next example, notice now we're dealing with base e. Okay, so if I have a base e integral, I'm going to be utilizing these two properties. So note my exponent is a function of x, 2 over x, right? That's 2 times x to the power of -1. So what I need is I need u prime in order to integrate. Well, u prime, the derivative of this is going to be -2 x to the -2nd, or x squared. Okay, so That's my reverse hook. I need that in order to integrate. Well, notice, okay, I have my x squareds accounted for here. Okay, so that's good. What I don't have is I don't have the -2, so I need to introduce that. Okay, and what I'm going to do, I'm going to simplify this. I'm going to rewrite this. I'm going to pull out the 1/3. So 1/3 times the integral of e to the power of 2 over x squared dx. I'm going to make some room. Dx. Okay, so again, I have the x squared. What do I need? I need a -2. So I'm going to introduce -2 here. Okay, and I have to balance that -2 with a -1/2. -1/2. Okay, so notice here is my reverse hook, okay, or my reverse chain rule. So when I integrate, that's going to go ahead and it's going to go away. Okay, so I'm going to integrate this, and this simplifies to a -1/6 out front times the antiderivative of e over 2 to the power of x. So that is e to the power of 2 over x. Okay, plus c. Oh no, I lost my place. Let's see where we are. Right here. Okay, plus c. All right, and that's it. There's your answer. Number 7. All right, on number 7, notice this is pretty nasty looking, but what you should see is the power function. So, I mean, make a note, right? I have this raised to a power. So generally the inside, I want to see, okay, like what's the derivative of this inside? Well, the derivative of the inside is e to the x, right? Derivative of e to the x is e to the x. And then derivative of this is also e to the x, so e to the power of -x, times the derivative of my exponent, which is a -1. So this becomes e minus e to the power of -x. And what I hope you see here is right here. Okay, so there's my hook, right? If I want to integrate this, I need the hook to go away. So that's going to go away. All right, so that's good news. And what we're going to do here is I'm going to rewrite this. So this will become the integral of e to the x plus e to the -x raised to the power of 4. And I'm putting this first because I want the hook to be next to my dx, right? Because that's going to go away with the dx. Okay? And this is a -4 because I moved it up. -4. All right. So we're going to go ahead and integrate. Our hook here is going to go away. Okay, and we get e to the power of x plus e to the power of -x. Okay, and my exponent, I'm going to add 1. That's -3. And I'm going to divide by that same value, -3. Okay, it's indefinite, right? No bounds, so I add a plus c. And there's your answer. That's it. All right, that is integrating exponential functions. There you have it. Catch you next time.